All right, Algebra 1. Here comes some factoring by grouping. Extra practice since we didn't get to all of these, right? We didn't get to all of them. Let's start with number 7b here, number 7b. So when I'm doing factoring by grouping, again, I got to group my first and second terms and third and fourth terms. Here's my grouping, my first and second term. Here's my third and fourth terms. And then I gotta find those greatest common factors. So I'm thinking, what's my greatest common factor? X squared and negative 2xy. That's going to be an x, right? If I take out an x there, I'll have x minus 2y left. Again, when I take it out, when I say take it out, I mean divide by x. Taking that common factor, I'm dividing it by x. Next, I need to think common factor of 4xz and negative 8yz. That would be a, let's think, should that be a negative or a positive 4, right? So I'm going to try and make this parentheses the same as whatever parentheses I have over here, right? So I can even write, I want to make sure that this looks correct, right? So how do I get from this to this? What common factor do I have to take out? So if I take out a positive 4, then I'll be just set for that. So if I take out a positive 4 z, that would be my common factor right here. I have a z in both, and I have a factor of 4 in both. So I'm able to solve that. So that my answer would then be x plus 4z, and x minus 2y. Okay. When we were talking about today unfactorable expressions like this, I was talking about something like this, and this won't be on any of your homework or quizzes or tests, but I think it's good for you to know, right? An unfactorable expression might be something like 13x minus 4 plus 7y minus, let's go 5. Okay, so none of these have a common factor. If we're just trying to regularly take out the greatest common factor, so we can think, oh, I can factor by grouping maybe. Then even if I look, my greatest common factor is just 1 in both of these. So that is not a valid one we should use finding the greatest common factor and factoring by grouping for. So that would be an unfactorable one. We would not have the skills to do that just quite yet. So that's something you won't see, but I think it's important to know that that can occur in math. This one, let's try this one, number 8. I'm thinking, what is my common factor between first and second, and then the third and fourth terms? First and second terms, my common factor is n squared, right? And when I take an n squared, I'm dividing by n squared on both terms. I'm left with n plus 2, right? I divide by n squared. My next one, I'm looking at taking out a negative 4, right? I want to take out a negative 4. I'm left with n plus 2. You say, Mr. P, why do we take out a negative 4? I want to make sure that these parentheses look the same, right? That's what we're looking for in factoring by grouping. So we can finish with n squared minus 4, n plus 2, and that's finished there. Okay? So if I had taken out a positive 4, I would be in a different situation. I had to have negative n minus 2, and that would not be the same as this parentheses. We want these to look identical, right? Make sure you take out that negative 4. All right, so let's move on to maybe something like 11. My two sets of parentheses, I'm thinking, what's my greatest common factor? That'd be 7x here. These are both divisible by 7, and they both share an x, right? Variable and number. Those x's should cancel. 14 divided by 7 is going to give me 2y, plus 35 divided by 7 is 5. Okay, now I have a 7x, and then I have 2y plus 5 inside my parentheses, so I'm going to need this parenthesis, if it's going to be factorable, to be 2y plus 5 as well. What do you think I should take out? Yeah, I should take out a negative 1. That would change all my signs, and I would be set up for 2y plus 5, and I'm set 7x minus 1, right? Greatest common factor of both of these in their own parenthesis, and then 2y plus 5 in the other parenthesis. Let's maybe do one more. Let's do 12. We have our setup here with our dual parentheses. 21 and 35 again have a common factor of 7m. We're left with 3n when we divide by 7m on both spots. And then we divide by 7m here. Those m's cancel. And we're left with 5, 3n plus 5. So then now we move on to our next set of parentheses. Greatest common factor looks like maybe a negative 5. Negative 5, I take that out, I'm left with n. So I'm dividing both these by negative 5. I'm left with, sorry, not n, 3n. Right? I divided by a negative, so I'm left with a positive 3n. And I divided negative 25 divided by negative 5, and I get positive 5, 3n plus 5, which is the same as our other one. So my answer is 7m minus 5 and 3n plus 5. And those are some more examples for you to practice and be ready for a quiz or a test, and especially be ready for Monday when we're going to be solving quadratics that do not have a being 1. Okay, so thanks for watching.